This video is intended to help you understand how you can do regression procedures, including making a scatter plot, calculating the correlation, finding the least squares regression line, calculating a residual plot, finding the confidence interval for one of your slopes, and doing some confidence and prediction intervals for your predicted response. The first thing we need to do is we need to run in the data. If we have vectors of data, then we can do it like this. Otherwise, we can do an import data set here, or using the read.csv command, we can run in a data set. Here, let's just use this example code. So this is the high school GPA versus college GPA, where high school GPA is our explanatory variable and college GPA is the response variable. If we highlight this section and run it, then we'll see that our new numerical vectors come up in this window, and it's also been run in the console window. The next step is, because we're looking at bivariate data, we want to look at the relationship between high school GPA and college GPA. We need to put the explanatory variable first, then a comma, then the response variable. So this will be the X and Y, and it'll go on the horizontal and vertical axes. This is just a basic scatter plot we can see here, where the variable names are on the horizontal axis and the vertical axis. So you can see, and we can see that there's a positive relationship between these two variables. However, this plot is not as good as it can be, so we want to add some titles and some color to our plot. We can do that by adding in a couple of these different features. The plot command remains the same, where we put our explanatory variable first, then our response variable. Then we'll put in main. This will be our title. So here, this is our title, and we call that main. We need to put the title into parentheses. Then if we want the point characters to have any sort of color, we can change this. I've had them as dark green. However, you can change this to orange, yellow, green, whatever you would like to change it to. You can change that here. Then you can change the point character. This will be the then characteristic that will show up as your point. I like just the solid circle. This is an open circle. This is point character 1. Here I want a solid circle, so I'm going to use point character 16. Online, there's several different resources that will show you the different colors that R has, along with the different point characters. You can also just mess around with this and change this value to see what comes up. All right, the X lab, or the X label, I'm going to actually call that now high school GPA. So there's an error in this. I'm going to change it. So the X label should be high school GPA, and the Y label should be college GPA. And the reason why I'm changing this is just so it looks a little bit nicer on the axes. All right, so now I can highlight this entire section and run it, and I get a nicer plot. I get a title. Notice that because I have this on two separate lines, it comes up on two separate lines here. If I want it on one line, I could just remove that, rerun it, and it'll all come up on one line. So that's something that you can change. And we can see that my point character is a nice dark green color. I could change this if I wanted to something else. Maybe I want it to just regular green instead of dark green. I can change this and rerun it and change my plot to be what I want it to look like. All right, so the next step in doing any sort of regression analysis is looking at our correlation coefficient. We can use the command core, so COR, where we put in the explanatory variable and response variable. It actually doesn't matter which order we put these in, just as long as they're both quantitative and the lists are of the same, so our vectors have the same number of units in them. All right, we get a correlation coefficient, comes down here as 0.8168956 or 0.82. That's a pretty high correlation coefficient. So there's a strong relationship between these two variables, which we can essentially see from our scatter plot. All right, the next step is to calculate the least squares regression line. So once we've added in our data, we can use the LM command, where our response variable here will be college GPA and the explanatory variable is high school GPA. We can use the command LM to get our least squares regression equation or least squares regression line. We usually like to call this something because we're going to use this model in several different places. Also, when we just run this command, so LM, it just gives us the very basic intercept and estimate for our slope. So we could just do this to find the intercept and estimate for our slope and get our least squares regression line. However, we want to use this in several other places to find residuals and to then calculate some other values. So let's call it something. I'm just calling it mod. You can call it whatever you'd like. And then take the summary of that output. Here, we then get the entire regression output that we are used to. If we want to open up this window a little bit more so we can see it. We can see that, I'm going to run this actually one more time so that it all comes up onto the one line. There we go. All right, so we have our estimate for the slope, and we have our estimate for the intercept. We have our standard errors that can be used for confidence interval calculations. We have our t-test statistics. This will be for testing whether or not there's a significant relationship between our explanatory variable and our response, and the p-value according to that hypothesis test. Here we can see that there's a small p-value in this example, so there's going to be convincing evidence that high school GPA is a significant predictor of college GPA. Also, some other things that I want to highlight here in this output is that we have our standard error. This is the estimate for sigma, the true variation around our population regression equation. And here is our error degrees of freedom, or the degrees of freedom that are always associated with our t-test statistics and our t-confidence intervals for our slopes. So that's 8 degrees of freedom here. In this example, that would be n minus 2, so 10 minus 2 is equal to 8. All right, so once we've gone over that, we can then move a little bit further into looking at our residuals. So we can calculate residuals using the plot command, where we use our explanatory variable on the horizontal axis, and then we use our residuals on the vertical axes. So here we can calculate our residuals by whatever we called our model. So here we called our model mod. We can pull up the residuals with this $sign command. So if I just highlight this section, I can see that these are the residuals for all of the points in my analysis. This is again the observed y value minus the predicted y value according to our least squares regression line. So this is the difference between those values. I can then plot these against the explanatory variable to get our residual plot. So if I run this line, I will get a scatter plot of the residuals here. Now what I really want is I want to also add a reference line at 0 so I can basically see whether or not our conditions have been met. Here, if I put this reference line of 0, I can use the command AB line. This will allow me to add any line to my plot. H means horizontal. I want it to be at 0, and I want the line type to be dashed, so that's line type 2. Here then, if I'm looking at my plot, I can see that there's generally random scatter, so I can move on to the next step, start making more inference about my relationship between high school GPA and college GPA. Here, the next step is to calculate the confidence interval for my slope. I can do that with the command confint, where I use the mod summary name. So basically this is the name for my linear model, use mod, and then I put in the confidence level that I'm interested in. I'm interested in a 95% confidence interval for my slope, so I'm going to use 0.95. Here I get then a 95% confidence interval for the slope, so with a 1 point increase in high school GPA, we would expect our college GPA to increase by 0.329 points to 1.22 points on average. So again, this is the 95% confidence interval for our slope, or our point estimate for beta 1. Now the last thing we'd like to do in regression is make a prediction about a particular value. Now we've learned that there are two types of predictions. There's a prediction of a single value, and there's a prediction for all values of that same value. So here we want to first do a confidence interval and predict the average response for all students who have a high school GPA of 3.6. So we can do that by using the predict command, putting in the model, That's the name of our linear model. And then putting in the data frame where we're defining what the new value for high school GPA will be. Here, this is going to be 3.6. So we're going to then make a prediction for college GPA where the students have a high school GPA of 3.6. The level of confidence will be 95%, and we'll be doing a confidence interval. Run this section. I get the estimate, so the fitted value for 3.6 to be 3.48, and the lower and upper confidence interval bounds to be 3.35 and 3.61. If I want to do a prediction interval, so to predict a single value for a specific student that scored 3.6 in their high school GPA, then I can run this line where, again, I use the predict command, use model, that's the name of my linear model, data frame, define the value of x, then use the level of confidence 0.95, can change that to anything I'd like, and then I can call this the interval as prediction to do the prediction interval. Here I see that I get a fit that is exactly the same as the confidence interval, which should happen, but I get a different lower and upper bound according to the prediction interval because there's a larger margin of error. So here I get 3.05 to 3.90 for the predicted values, upper and lower bound, for a single student that scored 3.6 in their high school GPA. This is how we can do several steps for simple linear regression in our software R and RStudio.